All right, so this is another example just to give you a better idea, give you a better conceptual understanding of the inflection point. So here we have a vase, this interesting shaped vase, right? Um, and water is being poured into it at a constant rate. Okay, so constant rate in liters per minute. Okay, liters per minute. and um, and so that means that the volume is changing at a constant rate. All right, but you can see that obviously the if you look at the cross sectional areas of this of the water at any given time, that's not the same. So it says the example asks us to graph the depth of the water with respect to time and explain the concavity and indicate the inflection points. All right, so let's just take a look at this. Now, water's coming in at a constant rate. So if I look at, say I look at this the first centimeter of water that gets added, so like let's say this is just 1 centimeter. That there's a certain volume to that. Now I could break this up into 1, 2, 3, let's say that. There's 1, 2, 3, 4, 5 centimeters of water. So if I look at this last centimeter of water that got added, you can see that it obviously has, so this is like 5 centimeters up, let's say. There's less volume in that last centimeter of water than in the first centimeter of water, okay? So it's going to take less volume to fill it, which means the depth is going to increase quicker because it takes less volume for the amount of depth. So as the depth of this thing, as a depth of the water increases, the amount of volume it takes for every centimeter of depth, it becomes less, right? Because the vase is narrowing down until you hit this halfway point. So let's say that this is the halfway point, right? And at that point, then the vase starts to become wider. Okay, so again, now it looks like the volume required for each centimeter is going to increase, right? So after the halfway point, the depth increases more slowly as the diameter of the vase increases. All right, so let's think about what that means as far as the graph, because we're really asked to graph this function f of t over time. All right, so let's try and do that. So I'm just going to draw some coordinate axes here. All right, and this axis will be time, and this will be the depth f of t over time. All right, so let's think about what's happening here. The depth is going to start out at 0, and then we start adding water to it. Now, initially, the depth increases slowly, but then the depth starts increasing quicker over time, right? And then it hits the halfway mark, and then the depth starts increasing more slowly again. So if we graph what that looks like, it's going to grow more slowly over time. And this point right here is essentially the halfway mark of the vase. That's where it changes, where the rate at which the depth is increasing changes. Okay, so this is our halfway mark. Halfway, okay. If this is our depth, right, this is the halfway mark in the vase. All right, so you can see that from graphing this, that of course the depth is increasing all the way along the curve, right? Because we're adding water. And so it's just going to keep increasing until it overflows. I suppose eventually it's going to just stop increasing and overflow. But you can see that the depth is always increasing. But at the beginning, it's increasing quicker, right? So the slope is increasing. The rate of change of the depth is increasing, okay? Until we hit this halfway mark, and then the depth starts increasing more slowly. All right, so this portion of the graph is concave up, right? Because the slope is increasing. And then this portion of the graph is concave down, right? Because now the depth is increasing more slowly. So the the rate of change of the of the depth is decreasing. Okay, the rate of change of the depth is increasing. The depth is increasing, but the rate of change of the depth is decreasing in this portion of the curve once we're past the halfway mark. Okay, so the other thing we can say is that the depth is increasing the fastest at the halfway mark, which makes sense because that's where the vase is the narrowest, so it takes less volume for every centimeter of depth at that point. Okay, but it's also the inflection point, right? The halfway point is the inflection point, so I can mark that on here. This is the inflection point, and it's where the depth is increasing the fastest. Inflection point. All right, so that kind of gives you a bit of an idea. And you can always think of the inflection point as being, it's the first derivative of the derivative, right? So it's the second, the second derivative is the derivative of the derivative. So essentially this, oftentimes the inflection point is the critical point, or a maxima or minima for the derivative, the rate of change of the function. All right, well, that's enough for that example, and I'll meet you for the next one.